Greetings, everybody, and welcome to our first problem in cardinal numbers and set applications. So what we're given here is a Venn diagram, and inside that Venn diagram for each region, we've got those numbers. And what those numbers mean are the cardinality for each one of those regions. Now, the regions that we have, if we go through and kind of label them, we've got region 1, we've got region 2, we've got region 3, region 3 here, and we've got region 4 on the outside. And so what this kind of set is really telling us is that the cardinality, so the number of elements in region 1, is going to be one element. The number of elements that we have in region 2, so region 2 is this overlap between A and B, has 3 elements in it. The number of elements in region 3 is going to be the elements in B that are not in A. Well, that has 8 elements in it. And finally, the number of elements in region 4 is everything kind of outside A and B, and we have 5 elements in that. And so the idea when we're asked the cardinality of this set, so for A prime intersect B prime, we really want to know what regions correspond to this particular set. And once we know which regions correspond to that set, then we can just add up the cardinality of those regions, and that gives us our total number. And so that's what we want to do. For this set A prime, remember that A prime is talking about the complement. Okay, and the complement, remember that is the regions not in the set. And so for the regions not in A, we look for all of the regions that are outside of set A. Well, for this, that's really just going to be our regions 3 and regions 4 for that. If we do the same thing for the complement of B, so we want the regions that are outside of B, well, that will be our regions 1 and our regions 4. Now, when we want the intersection, so what we're looking for the intersection, we want the regions of overlap. So anytime that you're seeing intersections, you're really kind of thinking common, either common regions or common elements in either case. And so what we have then in this case for the intersection of these two regions, well, we've got which regions are going to be in common. Well, the only region that is in common is region 4. So this will be only region 4. So the cardinality of region 4 only has 5 elements in it. And so the cardinality of the set A prime intersect B prime is going to be 5 elements. Now, if we want to do the same thing for the set A prime union B prime, now what we're remembering is that the union really takes everything. So it takes all of the regions in the first set, the regions in the second set, or the regions that are common to both. And so if we do that, in this case, what we have is that the regions in A are regions 3 and regions 4. But then we also throw in the other regions that we haven't already listed from B. Well, I don't have region 1 listed. I do have region 4 listed, so I don't need to list him again. And so in this case, A prime union B prime is going to correspond to regions 3, 4, and 1. So if we want the cardinality of those regions, we just say, all right, how many elements are in region 3? Well, region 3 has 8 elements. Region 4 has 5 elements. And region 1 has 1 element. Well, 8 and 5 is 13, plus 1 gives us 14 elements. And so our cardinality of A prime intersect B prime was 5. Our cardinality of A prime union B prime was 14. So I hope that this has been informative, and I will see you guys in the next problem. Take care.